everyone. In this video, what I'm going to do is I'm going to continue our discussion of disjunctions by practicing just a couple of problems. One that shows us how to do wedge out in practice, and another that shows us how to do wedge in practice. Let's get into it. Okay, let's take a look at our first problem where we're going to use these new rules are going to be in play. Wedge in and wedge out. So I've stuck them in the list here. This is the new recommended order, the recommended list of what to do. And this is the problem that we have. We've got T arrow B, Q dot G, arrow M arrow R, squiggle Q arrow X, squiggle X, G, and M arrow R, arrow M wedge T. And we're trying to get R wedge B. What we're going to do is we're just going to go down this list and see what we can accomplish. First thing we want to do then is look for, do we have any arrows not in parentheses? Yep, one there, one there. And this is a technique that we've been doing since quiz 2. There's one there, and one there. So we got 1, 2, 3, 4 arrows in view. Do we have any left side matches? T somewhere? Nope. Q dot G somewhere? Nope. Squiggle Q somewhere? Nope. M arrow R somewhere? Nope. Let's see if we can do modus tollens. Squiggle B somewhere? Nope. Squiggle X somewhere? Yeah. And actually I skipped one here. There's no squiggle M arrow R somewhere. But yes, this third arrow that we've got available, we do have the contrary of the right side, which means we can get the contrary of the left side. If the left side here is squiggle Q, what would be the contrary of that? That would be just plain old Q. And that would be modus tollens 3 and 4. Now then what we want to do is go back to the top of the list again. Is there another arrow out that we could do? Okay, now with this Q in play. Not immediately. So that might not be entirely obvious, but not immediately. So do we have a left side match for T? No. Do we have a left side match for Q dot G? Not exactly. I'll explain what I mean by that and then I'll keep going. Do we have a squiggle Q? No. Do we have an M arrow R? No. Can we do another modus tollens? No. There are no double arrows here that either I could take out or that I could build. Are there any dots that I could take apart? There's one dot here, but it's in parentheses. Are there any dots that I should build? So on the list, and in. Is there an and in I could do? The answer to that question is yes, because what you want to do is look for it on those left sides of arrows. Is there anything that you could build that would satisfy the left side? So here we don't need to build anything. Here we don't need to build anything. Here obviously not. Here, look at this left side of line 2. It's Q dot G. Do I have the pieces to build that? I just got one of them, and the other one's been sitting there since the beginning. So go ahead and build it. Q dot G and in 7 and 5. And now what that allows us to do is go back to the top of the list. Can we do an arrow out? Yeah. And we get M arrow R. Now this is another fresh arrow in view. But I'm going to go ahead and identify and see, like, oh, is there a left side match? No. But let's go back through all the others too. Do I have a left side match for this one? Nope, still no T anywhere. Left side match for this one? We just did it. Left side match for this one? Nope. Left side match for this one? M arrow R? Yeah. Look, we just got M arrow R. That's the left side match for this. That unlocks M wedge T. Arrow out 6 and 9. Let's go down the list. Arrow outs? None available. Modus tollens? Nope. Double arrows, again, not in play here. And out. Well, I mean, we could take this one apart, but that would get us pieces we already have, so there's no reason to do that. And in, again, we could and in anything, but we're not trying to get an and, we're trying to get R wedge B. And we don't have an R or B by themselves that we could just wedge in on. All right, I'll go ahead and say that now. Double negation, that's not going anywhere. Again, we can't do wedge in. Okay, if we had an R by itself or a B by itself, we could just tack the other piece on. So if we had an R by itself, we could say or B and wedge that in. But we don't have either one of those by themselves. So the next thing I want to look for is, can I do a wedge out? Now, here are the 3 things you want to look for in a wedge out. So I've explained the rule, but I want to explain it again here. So I'm going to put a little model over here. The first thing you want to look for, so here's your list. Okay, here's what you want to find. Do you have a disjunction? So it could be an exclusive or it could be an inclusive disjunction. Do you have one of these? And then, do you have also an arrow with one of the disjuncts, and that just means an or part. Do you have an arrow with one of the disjuncts on the left side? It doesn't matter what's on the right side. And also what you want to see is, do I have this other disjunct also on the left side of an arrow? In order to do a wedge out, this is what you want to look out for. Do I have an or statement? Doesn't matter which kind. It could be inclusive or exclusive. And then also, do I have one of the or parts on the left side of the arrow? And do I have the other or part on the left side of the arrow? So do we have that in play? Do we have an or statement somewhere by itself? Yup. There it is, line 10. So there's the or statement. So then I said the next thing to look for is, do you have one of the or parts? And technically this would be called the sinistral disjunct. And all that means is the or part on the left side
is this also on the left side of an arrow somewhere? So look, what's the left side here? M. Do we have M on the left side of an arrow somewhere? Yep, there it is. The next thing to look for is, do I have the other OR part also on the left side of an arrow somewhere? Yes, I do. Way up in line 1. So this checks out. So I've got this check, check, check. What that means is there's two possibilities here. Here's one possibility. If this is the case, and then on the right side of those arrows, I've got the same thing, that means I can just say that thing. So let's see, do I have the right sides of those arrows I was just looking at? So where I had, all right, so this M here, its arrow has R, and here this arrow has B. Are they the same thing? No. Okay, so this is not what's going on here. It's not redundant. Each one of the OR parts leads to two different things. So what happens when they lead to different things? Here's what's going on. I've got this thing or this thing. If this thing happens, it leads to this. If this thing happens, it leads to this. And what that tells us, if that's true, then that means one of the right sides, inclusive or 100%, or the other thing. Think of it this way. Let's say I've got either one of these ORs. It doesn't matter the type. And think of these as like slides. This is saying you've got a choice. You can go between one of these two slides. It could be inclusive. Like, hey, you can, like, say you're at a water park. You can go down one slide, and if you go down this slide, it leads to this pool. And if you go down this slide, it leads to the other pool. And let's say here, like right now, you have, it can be inclusive or exclusive. Like maybe you could go down and then go back up again and do the other one, or it could be the other way. Like, you have to pick one now. Right? You only get one choice. So one of these two things is happening. If you're given the choice between one of these two things, and this leads to this, and this leads to this, then one of these two things is happening. So that's what you do here. That's what's going on. You're saying, all right, one of these two things is going to happen. So in this case, applied in the problem, M or T is going to happen. Maybe both, because it's inclusive OR. If M happens, then R is going to happen. If T happens, then B is going to happen. So what we can do here is this is just like arrow out and stuff, we just plug this into what's actually going on in the situation. So that gets us line 11. Okay, M or T. M leads to R, that's corresponding to C in the model, or T leads to B. Okay, that corresponds to D in the model. So we get R wedge B. Yep, look, that's what I wanted to get. How did we get it? This was wedge out. And then we cite our sources. And so here's the order in which I cite them. Where was the OR that you used? That was in line 10. Where was the piece that you used where the left thing of the OR part was on the left side of the arrow? That was in line 9. Where was the piece that you used where the right OR part was on the left side of an arrow? That was way back in line 1. And the order doesn't matter here. You could say 1 9 10, 9 1 10, 10 9 1. Any combination is fine. As long as it's the right numbers, you're good. This problem is done. But the thing I would really want to emphasize is sometimes I'll see people make this mistake. This is a grievous error. So they'll have something like this, like R wedge B, and they'll go, oh, I can just separate those. So let's say I had this in line 1, and I'm saying here, you cannot get these. Nope, nope, nope. And they go, oh, that's R, and that's B, and that's a OR out on line 1, and that's an OR out on line... No, 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 no. You can't just take ORs apart. And here's why. Remember, all it takes is one piece of a disjunction to make it true. So let's say this was something like, assuming that it's actually Wednesday, today's Wednesday, or I'm the King of France. If you take these apart, all of a sudden today's Wednesday, that's true, but now I'm the King of France is also true. So that's why you can't just take OR pieces apart like that. Like, I think of them this way as like slides. This thing leads to this thing leads to this thing. You take one of these routes, you're going to go here. So another example of this would be something like, I can take I-20 East or I can take I-20 West. If I take I-20 East, I'll end up in Columbia. If I take I-20 West, I'll end up in Atlanta. But it's an inclusive disjunction. Doesn't mean that just because I go to Columbia, it doesn't mean I can never go to Atlanta. And just because I go to Atlanta, it doesn't mean I can never go to Columbia. It's still inclusive, even if we're saying, no, today you have to pick one. Okay, it doesn't make it impossible for the other thing ever to happen. That's why the result is always going to be a wedge. You're never going to have, there is no such thing as like an XOR out. It does not exist. Okay? Does not happen. So this is one example with disjunctions. Let's take a look at another one. We've got A arrow B, B arrow C, and we want to get A arrow C wedge F. Looking at this problem, here's something to take note. If your goal is a wedge, and one of the pieces is simply not there to be found. So look, do you see an F in here anywhere? I don't. That means that there is a 99% likelihood, in fact, I think in this case, if that's nowhere to be found, there's a 100% likelihood that your last move is going to be a wedge in. You're going to say or F to getting this. Let's go about our business normally. Do we have arrows? We sure do. Left side matches? Nope. Right side contraries? Nope. Go down the list, no double arrows. Can't do an and out, can't do an and in, it doesn't go anywhere. Can we do a double negation? No. Can we do a wedge in right now? We could. I mean, we could totally get something like A arrow B or F, wedge in, and where do we stick that F onto? Line 1. You could do that. It's not wrong. It just doesn't take you anywhere. So can we do a wedge out? Definitely not. We don't have a wedge to start with right now. Is our goal an arrow? No. Our goal is a wedge. But I already told you that we've done stuff like this before. Look and see what are the pieces here. So if I look at this, if I could add this on and I could to this, well, let me get this first. What would this include? What do I need to get? Is it an arrow? It sure is. Which means in order to get this thing, A arrow C, if I PA the left and I get the right, I've got this, and then I can just add an F onto it. So let's do that. Line 3, let's just say A. Provisional assumption, this is for an arrow in, so we're going to go after C. Can we get the C? Now can we do an arrow out? Yep, we get B, arrow out, 1 and 3, and then we're able to get C with another arrow out, 2 and 4. Side quest complete. Now we can say, yep, A arrow C is a thing. This is a quiz 3 move here. Arrow in, 3 through 5. Now look, we've got half of what we need. We have the A arrow C. So how do we get from A arrow C to or F? We just add, literally, the move wedge in is called addition. You just take that A arrow C and you add an F onto it. The way you do wedge in is you say, what did you stick the thing onto? So this thing is kind of spontaneous. It almost seems impermanent, but what you're doing here is with ors, as long as one part is already established, you can say or anything. So what we do here is we just say, what did we add it onto? Wedge in. What do we stick the F onto? Line 6. Problem solved.
So that was a little bit of practice with wedge out and wedge in. What I'm going to do in the next video is I'm going to go over some other rules that are different from a lot of the rules that we've used so far. The rules of substitution as opposed to rules of derivation. Basically, it allows you to swap something out for something easier to use. See you next time.